Today we are going to discuss about the Newton's first law of motion. Humans thought that a moving object on its own will come to rest if you do not apply any force. And on the other side of things, if you want to keep an object moving, you have to keep applying a force to it. We've never in our everyday experience seen an object that just keeps moving on and on forever without anyone acting on it. It seems like something will always stop. And this is why, for most of human history, probably prehistory, until the early 1600s, so for at least 2,000 years, the assumption was objects have a natural tendency to stop. These gentlemen show up in the 1600s, and you might be surprised to see three gentlemen here, because this is about Newton's first law of motion. And, indeed, one of these gentlemen is Sir Isaac Newton. But these other two guys get at least as much credit for it because they actually described really what Newton's first law describes, and they did it before Newton. This is Galileo. And this is René Descartes. These three gentlemen said, maybe it works the other way. Maybe objects have a tendency to maintain their velocity, their speed and their direction. And if their speed is zero, they'll maintain that restfulness. Unless they're acted upon by an unbalanced force. Objects have a tendency to maintain their motion forever. And the only way that you're going to stop them is if you act on it, or accelerate them, or change their velocity. So either their speed or direction some way is to act on them with an unbalanced force. The tendency to stop is because of interactions with their environment. Because of this, forces are being generated that are acting against their motion. It's the interaction between the block and the ground. So, when you think you're leaving the block alone, you actually have a net force going against its motion, which is the force of friction. And these gentlemen realized that because they said, look, if it was an innate property of the block, regardless of the environment, it should always come to a stop, in maybe a similar way. But they saw that if you made the surface a little bit smoother, this block would travel further and further. If you made this surface completely frictionless, completely smooth, the block would travel forever. Newton's first law states that if a body is at rest or moving at a constant speed in a straight line, it will remain at rest or keep moving in a straight line at constant speed unless it is acted upon by an unbalanced force. The reason why they say unbalanced is because you could have two forces that act on something, and they might balance out. For example, I could push on this side of the football with a certain amount of force, let's say 5 Newton. And if you push on the other side of the football with the exact same amount of force, the football won't move. And the only way that it would move is if there's a more force on one side than on the other side. Now we are going to discuss about inertia. Inertia is the resistance of any physical object to a change in its velocity. The inertia can be measured in terms of the mass of an object. The greater the mass, greater the inertia. For example, a truck will have more inertia than a car, that is, the truck has more tendency to resist a change to its velocity. There are three types of inertia: inertia of motion, inertia of rest and inertia of direction. Let's discuss about inertia of motion. The inertia of motion is the tendency of a body to move with the same speed. For example, when a bus stops suddenly, the passenger tends to bend in the forward direction. Now let's discuss about inertia of rest. The inertia of rest is the tendency of a body to remain at rest. For example, when a car starts suddenly, the driver tends to bend in the backward direction. Now, let us discuss about the inertia of direction. Inertia of direction is the tendency of a body to resist a change in its direction. For example, a ball attached to a string rotating in a circular path when cut, moves in a path tangential to the circle. That is, it moved in the direction in which it was facing at the instant the rope was cut. With this we come to the end of today's topic, Newton's first law of motion. Hope you enjoyed it. Thank you for watching.